Hello, welcome to Management Science Studio. I'm Vahid Lotfi and I'm an Emeritus Professor of Management Science. In this video, I will demonstrate how to create sampling distribution of the mean using Microsoft Excel. I will do this using randomly generated samples of different sizes and then compare the results. So let's get started. The database that I'm going to use consists of 1-year returns of 540 5-star rated mutual funds. These are fund numbers 1 through 540, and in column B we have the 1-year percent return, and that is for the year 2023. First, I will look at the population statistic, including the count. Well, we can type in the number, which is 540, or do the count command this way. I'll then calculate the minimum, maximum, the mean, which is the average command, the variance, and we are going to treat this as a population, so this will equal to var, and I'll make sure that I'll take the population variance. And finally, the standard deviation, which is equal to the square root of variance, which is in E6. So those are my population statistics. Now I will show you how to do random sampling, and there are two ways to do that. One way to generate a random sample is by the use of the rand function, which generates random number values between 0 and 1. So I'll just call this the rand here and type in the function equals to rand, parentheses, and close. And notice that each time I type a value in a cell in Excel, a new random number is generated. For example, if I just type a 1 here, we get another number. Now I'm going to copy this formula all the way down to the last row. Go ahead and reduce the number of decimal places. And make it a little bit larger. Now, in order to generate a random sample, what we will do is we will sort the random numbers from largest to smallest, and then select the top 5 or 10 or 30, whatever size random sample you wish to generate. So I will go ahead and highlight my data first, right there, and go to the data command and select sort and select rand. We're going to sort on the random number column, and we're going to go from largest to smallest and click OK. And now I have sorted my data on 1-year returns as well as rand from largest to smallest. But notice the random numbers change each time we click a column. So now I'm going to select the top 5 numbers as my sample number 1. Notice that the random numbers change, but the values of the 1-year returns don't change. So here's my sample number 1. This is the long way of doing it. A shorter way of generating samples, random samples, would be to use the Excel sampling command. So I'll place my title for sample number 2 here, and then place the cursor here, go to data and select analysis, and then select sampling. Highlight my input range, which is going to be my data. Random sample of size 5, and I want my output range to be right below my label right there, and click OK. So here is our second random sample of size 5. I am going to generate in total 20 random samples of size 5, but in order to save time, I'll go ahead and generate them first and then come back. So here are my 20 samples of size 5 each, and my objective is to compare random samples of different sizes and show you what happens as the sample size gets larger and larger. So for that reason, I'm going to calculate the mean for each of these samples. The mean here, the formula is going to be average, and the average is going to be the 5 observations in the first sample, and then I'll just copy that formula all the way to sample number 20 and reduce the decimal place a little bit. Okay, using the same procedure as above, I'm going to generate 20 random samples, this time of size 15. So let me just copy the headings and I'll just place it right here. Same thing, I'll show you how to generate the very first sample and then go ahead and put in the samples later. Data, analysis, sampling. Notice I don't have to change the input range, I just need to change the sample size and the output range, which is going to be here, and then I'll just click OK, and I get a random sample of size 15. I'm going to skip the demonstration of generating the next 19 samples and then come back. Here are my 20 samples of size 15, and using the same procedure I am going to generate 20 samples of size 30. So here are 20 random samples of size 30. My goal is to show you what happens to the sampling distribution of the mean as the sample size gets larger and larger. For that purpose, I'm going to copy the sample means for the 3 sets down here and then try to graph them. I'll label this as n equal to 5, label this as n equal to 15, and this row as n equal to 30. Then go ahead and copy the means. We must make sure when we do the copy and paste, we paste the values, otherwise relative cell addresses will be copied and that would change the numbers. So these are the means for the second set of samples, and we'll just paste them here. And finally the third. We can now graph these 3 sets of sample means and then compare them. So we'll just highlight the data, go to insert, and I want to create what is called a combo mean so that I can compare them together. make sure this is clustered as well. Click OK. And here's my chart. Looking at this chart, we can see that the means of the smaller sample with n equal to 5, the blue color, fluctuate quite a bit. We go up and down. Remember that our original population mean was 16.8. When we go to the slightly larger sample size of n equal to 15, the orange color, the fluctuations reduce somewhat. And lastly, when we go to n equal to 30, the fluctuations are quite a bit less than the other two samples. Now this graph is useful in comparing the sample means of the three sets of random samples. I am actually going to develop a frequency distribution of the sample means and graph the frequencies, and that would give us a much clearer comparisons. I'm going to move this chart to the side and then begin the process of developing the frequency distributions. If you're not familiar with how to do frequency distributions and or histograms in Excel, please go to Management Science Studio and watch my video on how to do histogram and frequency distribution. So I'll calculate the mean for my data to determine what class size I'm going to need, and then I'll calculate the maximum. And so we can see that my data goes from about 8 to 25. For the bin range, I'm going to start at 10 and then go 2 points at a time, and I'll probably go to 26. Now I'm ready to develop the frequency distribution, so we'll go ahead and data, analysis, select histogram, okay, and then my range for the first set of data, and then the bin range, and an output range. I'm going to skip the demonstration of the frequency distribution for the other two data sets and then come back. Here are my three frequency distribution. That one was, the first one was n equal to 5, this one is n equal to 15, and this one is n equal to 30. I'm going to copy the frequencies. Actually, I don't need more, so I won't go there. Copy them and place them here. This would be n equal to 5. And then copy these numbers, place them here. This is n equal to 15. And lastly, these numbers, these are n equal to 30. So I'll go ahead and highlight my data and then select insert and go ahead and do a scatter plot and select this one, and here is the chart of the frequency distribution of the sample means, and we can see that the sample means of the samples of smaller size, like n equal to 5, the blue color curve, fluctuate quite a bit. For the relatively larger samples of n equal to 15, we get a slightly better curve. And lastly, for the larger sample of n equal to 30, we get a curve that is very close to a normal distribution. So one might ask, why is it so important that the sampling distribution of the mean becomes closer and closer to a normal distribution? The answer is that normally we do not know the population parameters, and we use the samples to estimate the population parameters. And when we have an approximately normal distribution of the sample mean, we can use the standard normal distribution or the t-distribution to develop confidence intervals of the mean and therefore get a more precise estimate. And that is how we use Excel to generate random samples from a data set and also explore the sampling distribution of the mean.